4.6, we looked a little bit at like one example that had a u sub with a natural log, but we're going to go a little bit more in depth with it now. So in general, remember that the integral of 1 over u du is the natural log of the absolute value of u plus c. Now remember that our natural log cannot have negative values on the inside, which is why if we're going backwards, we have to add in that absolute value, because we don't necessarily know what values it is that we're plugging in. So we're going to look at a kind of basic one first, and then look at ones that have a couple more steps instead. Let's look at some examples. So I have the integral of 1 over 4x minus 1 dx. So what do we want to let our u be here?
4x minus 1.
Yeah. Couple people still writing. Wait a second. So then remember that we also have to now change our dx into terms of u. So I'm going to take the derivative of both sides. So I get 4 dx. Do I have an extra 4 in my equation?
No.
No. So what do we got to do?
Divide by 4.
Easy enough. So this one's very similar to the one that we did in last section. Okay, so I'm just going to have a 1/4 integral of 1 over u du. So now, what is the antiderivative of 1 over u?
Natural log of absolute value u.
Yep. Plus c. This is an indefinite integral, so we do have to put our 4x minus 1 back in there. Yes, no, maybe so. Okay. Alright, what do we have on this one?
A lot of x's.
A lot more x's, okay? Do we notice anything about our x's?
You can factor out 1x from the denominator.
You
factor it off to the side.
can. It's not going to be super helpful to do that. It would only be helpful if I could also factor out an x from the top. Do we notice anything else? What's the degree of the top?
2
Degree of the bottom.
3.
So if I take the derivative of the bottom, what am I going to end up with? A degree of what?
2.
2, which is our numerator, agreed?
Mm-hmm.
So we're hoping that if I do a u sub, what would we let our u be?
X cubed plus x.
Yeah, so our denominator, right? Because we want our u to be something that has its derivative in our equation. Yes? If it was the opposite way, where our u needed to be on top and the du was on bottom, that's not going to work, and we would have to do something different, which is what tomorrow is about. Yay, long division. Okay? So, but for this one, we are good because our u is on bottom, because x cubed plus x. If I take the derivative of that, what do I get?
3x plus 1.
3x
Squared plus
squared plus 1. And do we have a 3x squared plus 1 in our equation?
No. The 6x squared plus 2 though.
Okay.
Divide that by 2.
Almost. I can't just divide it because then that changes the like value. But what can we do that's kind of like dividing but just moves it for us?
Distribute 2 out.
Taking it out.
Yeah, taking it out, so
Factor
undistributing, right? So we're going to factor it out. Agreed. So notice if I factor out a 2, I am left with a 3x squared plus 1 on top, which is now helpful that's what my du is. So I'm just gonna pull my 2 out to the front. This now becomes my du, and I have a u on bottom. So again, what's our antiderivative here?
Natural log of the absolute value of u.
Okay. Now I still have a 2, so that still has to stay. And then again, we have an indefinite integral, so I'm going to plug my x's back in. What questions do we have there? What do we have here?
Natural log of x.
We have a natural log to start with. Okay. So what have we been letting our u be?
The denominator.
The denominator. Okay, what's our denominator here?
X.
So if I let my u be an x, what would our du be?
Du. Or dx.
Yeah, is that going to be super helpful? Okay, so do we have another option for our u?
Natural log of x.
Agreed. So notice that we also have a fourth power. So instead of our fraction representing our outside function, right, which is what our last couple have been, our fourth power is going to be acting as our outside function. So we're going to let our u be the natural log of x. So then our du is 1 over x dx. So I have a 1 over x dx.
Mm-hmm. Yeah.
Yes, no, maybe. Do we agree? If you can't quite see it, remember that dividing by something is the same thing as multiplying by the reciprocal. So we could technically write this like that, right? Dividing by x is the same thing as multiplying by 1 over x. So then I just have u to the 4th, and now my 1 over x and my dx are getting like scooped up by my du. So then what is the antiderivative of u to the 4th?
5u over 5. Or u to the 5th over 5.
Yeah, 1/5 u to the 5th plus this. Now, do be careful here, because that whole natural log is being raised to the 5th power, not just the x. So you do have to have parentheses around the whole thing. Otherwise, if you don't have parentheses, then you're saying the natural log of x to the 5th instead of saying the whole natural log of x raised to the 5th power. Question. Okay. Alright. So this would be a nice example of a free response type of question. So it says find the area bounded by the following equation. The y-axis and x equals 3. So what might it be helpful to do first?
Write out the interval.
Do I know I need an interval right now? What might it be helpful to do before that? Yeah, draw a picture, right? So like I got a lot of words there, and we're talking about a graph and the y-axis and x's, yeah, right? But like that is helpful to at least have somewhat of a visual thing to look at. Now, even if it's not the most accurate thing in the world, that's fine, but it does help us to have a visual. Because at the end of the day, I don't know So x is going to be positive and x squared is definitely going to be positive. So I know it's going to be positive. Okay, so I know it is like above my x-axis somewhere. That's not what that graph looks like. But again, we're just trying to get a visual of what's going on here. So then it says that that's, again, pretending that that's what my graph looks like. It says the y-axis, so I'm looking at this right here. And then what is x equals 3?
A vertical line at 3.
So then it does see that I want the area bounded by all of that. So we are looking for this right here. And now this technically was the last part of this chapter. However, we still do have to be able to refer back to this. What does an integral represent?
Area under the curve.
Yeah, so we are going to take the integral. Okay, what are our bounds going to be?
0 to 3.
Okay, and then we're just taking our x over x squared plus 1 dx. Okay, and I want you to work out that one on your own. It's going to be very similar to what our last couple were. now I'm going from 1 to 10 now instead. So notice that if I plug in 10, I'm just going to have 1/2 natural log of 10. And then subtracting, what is the natural log of 1? It's 0. So I would be subtracting 0, so I don't really have to put anything there. So that would be your answer. The only other thing that you could see is remember that constants in front can be rewritten as an exponent, and then 1/2 as an exponent is a square root. So we could write it as the square root of 10 instead. But again, free response question, you're fine with the 1/2 natural log of 10. What questions do we have there? Now, here is the one as promised, tangent. Bless you. So recall that we do not have a rule for tangent. We have a rule for secant squared, right? The antiderivative of secant squared is tangent, but I don't have an antiderivative for tangent in and of itself. Yes, no, maybe. And the reason is because it requires u sub in order to be able to do that. So tangent is one of our trig functions. So if I don't have a rule for that, then I need to do something else to it. So how can I rewrite tangent?
Sum of cosines.
And the other nice thing about sine and cosine is remember that they are also each other's derivatives. Again, if I have a fraction, my go-to is to want to put my u in the denominator if at all possible, which in this case we can because now du is going to be the negative sine of theta d theta. Hopefully, again, that looks vaguely familiar. So again, my antiderivative is going to be the natural log of the absolute value of u plus c. So we can plug in our u, which was cosine, which tells us that the antiderivative of tangent of theta is negative a natural log of the absolute value of cosine of theta plus c. Which you have one of two options. It comes up every once in a while. To me, it's not something that comes up enough that you need to memorize that. However, you do need to be able to do a u sub, which this is a fairly easy u sub. So as long as you remember to rewrite it, we should be able to get to our formula fairly quickly. What questions do we have there? Alright, so then let's apply that. Remember, average value was also from our first unit in this chapter. However, we can still do it with things that now require u sub. So what do I do in order to find an average value?
It's like 1 over b minus a times the integral of the function.
Yeah, from a to b, but yes. Basically, I have 1 divided by b minus a times the integral from a to b of whatever f of x is. So in this case, my b is pi over 4, my a is 0, so pi over 4 minus 0 just gives us pi over 4. And then we're going from 0 to pi over 4 of tangent of theta, sorry, I have an x this time, tangent of x dx. Now, like I said, we don't have to memorize the formula, but we did just derive it, so we might as well just use that. dividing by a pi over 4. That can get flipped to 4 over pi. And then I have the natural log of the absolute value of cosine of x. And I'm evaluating from negative pi over 4. Yes, no big. And that's just using the formula that we got on the previous picture. So then which bound do I plug in first? Okay, something that looks like that. Have I evaluated my function? Like, have I evaluated my integral function? Did I plug in my bounds? Yes, which means that we have evaluated our integral. Okay? So anything else from there would just be like numeric computation, which we do not have to do. So if we struggle with our trig values, stop while you're ahead, and that is a fine answer. Now, if you happen to remember, cosine of pi over 4 is square root of 2 over 2, and cosine of 0 is 1. So we get the natural log of square root of 2 over 2 minus the natural log of 1. Well, the natural log of 1 is 0. So we just get the natural log of the square root of 2 over 2. However, that's still not a super pretty answer, so it didn't help us all that much to evaluate them, so it's okay to just leave them like that. What questions do we have there? Yes, no, maybe so.